Hi students, today we will discuss a very important derivation about the simple pendulum. So normally question asked what is a simple pendulum and derive the expression for its time period. So now we see what is a simple pendulum. Simple pendulum means a bob that of very small mass that will be suspended by a string from a rigid support, and the string is that is flexible, weightless and inelastic in nature. So you see, suppose this is a rigid support and this is a simple bob. So this bob is supported by a string of length L, and suppose this bob is taken to this place A. So here you see the different forces acting on the bob. So its weight will be acting in the vertically downward direction and the tension will be along the string. So you know, कोई भी बॉडी है उसका जो वेट होगा वो ऑलवेज वर्टिकली डाउनवर्ड डायरेक्शन में होगा. So mg will be in this direction. Now mg weight is a vector quantity, so we can resolve this mg into its two rectangular components. So we will get mg cos theta along this direction, that is the horizontal component, and this one will be the vertical component. So this will be your mg sin theta, right? So now you see this angle theta and this angle theta, this is like a circular motion. So if this is L, this is theta, and this displacement is suppose x, so we can write this is the length of the arc. So we know the relationship that theta is equal to length of the arc. So in this case this is your x and the radius, so radius will be your L, right? So this is the value of theta. Now what are the restoring force acting on this body? So you see, if the body is taken to certain height, तो इसका जो रिस्टोरिंग फोर्स होगा इसके ऊपर जो कंपोनेंट है टुवर्ड्स द मीन पोजीशन. So this restoring force is your mg sin theta. So here we can say that the restoring force will be your restoring force that acts, that is along this direction towards the mean position. So this will be mg sin theta. So I can write this one as minus mg sin theta, right? So similarly you see here this sin theta, we can do its expansion. We know in trigonometry that sin theta can be expanded in its form theta minus theta cube by 3 factorial plus theta to the power 5 by 5 factorial, like that. So in this expansion you see, if the theta is very small, so what we can do, we can neglect its higher powers. So now if theta q, theta 5, that all are neglected, so we will be having only theta. So what we will get now, we will be getting your f is equal to minus mg theta. Here you can write minus mg. For theta I can write x by L. So this will be minus mg x by L. And you know what is your force? Force is equal to mass into acceleration. So we will be getting your acceleration is equal to minus g upon L into x, right? So this is the expression for the acceleration. Now you see, in this type of motion the acceleration is directly proportional to the displacement and it always acts towards the mean position. So you know what is a simple harmonic motion? The motion in which the acceleration is directly proportional to the displacement and always acts towards the mean position. So the conditions are fulfilled here. So we can say that this simple pendulum is executing simple harmonic motion, as your acceleration is directly proportional to x and towards the mean position. So once the body is executing simple harmonic motion, we already know that The simple harmonic motion can be represented by a differential equation, and from that equation we already know that d square x upon dt square, that will be minus, that is omega square x equals to 0. We already know from the previous classes. So this will be your a. So a will be equal to your minus omega square x, right? So if this we are taking as equation 1 and this is your equation 2, so by comparing this equation 1 and 2, what we will get? By comparing equation 1 and 2, we will be getting here that your omega square is equal to g by L. Omega square is equal to g by L. So what will be your omega? Omega is equal to square root of g by L, right? So now what is the time period? So time period, you know, that is 2 pi by omega. So here we can put the value. Your time period t will be equal to 2 pi by omega, and for omega I can write here, this will be square root of g by L. So this will come as 2 pi square root of L upon g. So this is the expression for the time period of a simple pendulum. So here you see what we have to do actually. हम 2-3 स्टेप में इसको कर सकते हैं. Simple pendulum करके we can draw the different forces acting on it, and from this हमें ये मिल सकता है कि जो A है वो डायरेक्टली प्रोपोर्शनल टू डिस्प्लेसमेंट है और ये टुवर्ड्स द मीन पोजीशन है. सो दैट मीन्स दिस विल एग्जीक्यूट इन सिंपल हार्मोनिक मोशन. अब सिंपल हार्मोनिक मोशन में हमने डिफरेंशियल इक्वेशन ऑलरेडी पढ़ा हुआ है, तो उससे हम कंपेयर करके फाइंड आउट कर सकते हैं दैट ओमेगा विल बी स्क्वायर रूट ऑफ जी बाई एल. सो नाउ टाइम पीरियड टी इज इक्वल टू 2 पाई बाई ओमेगा, सो वी कैन राइट 2 पाई जी बाई एल. सो दिस इज 2 पाई स्क्वायर रूट ऑफ एल बाई जी. अंडरस्टूड? सो सिमिलरली एक क्वेश्चन नॉर्मली पूछता है व्हाट इज सेकंड पेंडुलम. सो सेकंड पेंडुलम मीन्स द सिंपल पेंडुलम व्हिच इज हैविंग ए टाइम पीरियड ऑफ 2 seconds. Time period of 2 seconds. So sometimes it is asked ki what will be the length of a second pendulum. So we can find out the second pendulum. So you know what is a second pendulum. So second pendulum means the time period is 2 seconds, right? So in the question it asks normally find out the length of a simple pendulum, second pendulum. So how to find out? We know t is equal to 2 pi square root of L by g. So now squaring both sides, we will be getting t square is equal to 4 pi square L upon g. So here we need L. So L will be equal to t square g upon 4 pi square. So here we will be putting the value. So here we will get 4 into 9.8 upon, this will be 4 into 3.14 square. So if you calculate, the value will come as 0.99, right? So here we can tell the length of a second pendulum will be 0.99 meter. So this is a very simple question, but most oftenly it is asked in your CBSE 11th annual exams, right? So I think this concept is clear. Thank you.